Hello, I will be presenting the paper Memory Based Model Editing at Scale. Essentially, for this paper, it kind of details a new knowledge editing method for LLMs. Um, so, essentially, the motivation behind the paper and research itself was that the current model editors up to that point. Um, it made local updates to the behavior of the base models, and what happened is that it struggled with intended scope, edit performance, compute efficiency, and practicality. And so the authors of this paper created essentially a new model editor called the semi-parametric editing with a retrieval augmented counterfactual model, or for short SERAC. And it's a gradient free, and it caches edits. So no edits are actually done to the base model, and it learns to use these cache edits when necessary. We'll get into that later on. And it is made up of a cache, a scope classifier, and a counterfactual model. Um, and I guess just more briefly, just to go over the entire model itself. So basically, what happens is that you can think of SERAC as kind of like a wrapper around this base model right here. So, oops. This base model, SERAC is basically like a wrapper around it. And what it contains is that it has this edit memory. So you can essentially give this SERAC um, memories that or edits that you want to make, and basically it'll cache them, which is what I explained before. And what happens is that from this edit memory, we have like two examples up here. We have an X1 test and X2 test. Here for the X1 test, it says is messy at Barca, and this scope classifier will determine, okay, is my input within the scope of any of my edits in my edit memory. And here we have an edit memory, or an edit where it edited where does messy play, and the answer is PSG. Um, and so the scope classifier says, okay, since the example fits within our scope, we're going to put it through the counterfactual model of SERAC. And basically, what it's going to do is that it's going to output from its using its edit memory, and using I guess what it has stored, output the result of the question is Messi at Barca, which is no. But in the case of why is the sky blue, we see that in these examples, in these three edits, there's no correlation. So the scope classifier would say, okay, just go through the base model, and then um, depending on what your base model is, it'll output this Rayleigh scattering for the answer. So it wouldn't go through this counterfactual model, but it will go through the base model. And you can kind of see how SERAC is just a wrapper, in the sense that there's nothing being done to the base model. No, I guess weight updating, in other methods like Rome or Mehmet, that you may have seen. This is just giving a cache of edits, and basically having a scope classifier determine, okay, is my input within the scope of any of my edits? If it is, go through the counterfactual model. That's part of SERAC. If not, go through the base model and give me an answer. So I guess more precisely, this would be mathematically, it will be represented in this F tutor representation. We have X as the input, F base as the base model, G phi as the scope classifier, H psi as the counterfact model, and ZE as the set of all edits. Um, and to dive more into, I guess, what the scope classifier is. So here, this is just one example of the edit scope. Given one edit that you want to make, and one edit inputted into the SERAC model, this would be kind of like the scope of what examples could lie into what the scope classifier will classify as in scope or out of scope. And so here we have kind of like hard in scope and out of scope examples. So like this circle is like really close on the border, like it's almost out of scope, but it's like on the border of being in scope. And so are these like square ones which are just out of scope of like our edit. And so like this is kind of like the desired effect, right, of like one edit. And when you have like multiple edits, it's just think of like multiple of these green blobs, I guess like in like a space of like examples, like more of these kind of uh questions or inputs. um so yeah, and the desired functionality of the scope classifier is to obviously try and be as accurate as possible, and you want to change the behavior for the in scope examples, but to not change the behavior of like out of scope examples. So like here, who is the UK deputy prime minister? You don't want to change that answer because that doesn't relate to like who is the PM of the UK. So like the answer would be like in this case Boris Boris Johnson. And you don't want to change this because uh, this isn't related to, I guess, like the edit, but it's really close, right? So yep. Um, and then so for the a scope classifier, it's essentially kind of like a model itself, where it's learning what I guess like it's kind of learning what it has to classify as in scope or out of scope. So we have to train it on kind of like a certain data set that we generate. So that's just a quick overview about that. And then the counterfact model is just kind of like a normal like model. If you go back into the paper, you can actually see what models they used in the implementation details. So for the classifier, they use the Distill-Burt base case model, and then for the counterfactual model, they use the T5 small. So yeah, these are just kind of like normal like models that are already like pre-trained and whatnot. Um, and then for the evaluation for the paper, so essentially what we've gone over for the paper is kind of like the abstract, the introduction, explaining like what it is, and kind of like the inner workings of the SERAC model. So I guess like more into like the data sets and how they evaluate it. So for question answering prompts or QA prompts, they use the ZSRE question answering problem like data set. For fact checking or FC prompts, they use the vitamin C fact verification data set. And then for the dialogue generation or DG prompts, they use the ComSet data set. And then for the evaluation metric, the paper used like edit success and drawdown. And essentially, what you need to know is that the higher edit success and lower drawdown equals better, and vice versa. And then you can see kind of like in the papers on the results that they did. Um, I gave the example, but this is the graphic that is in the slides. But here we can see how with SERAC, the edit success minus the drawdown values is very much better than ENN or MEND editing techniques. But I will say that one of the concerns for this is that this starts drawing like showing like regression at 75 edits, which is not very many edits. And so tasks like or research papers like Rome and Mehmet and those kind of editing techniques solve this issue essentially, or make the number of edits like possible much greater. But yeah, that's essentially like what SERAC is again just a wrapper around a base model, and basically it has a cache of edits and the scope classifier. When you input something into the model, input like, oh, where does Messi play, it'll that input will go through the scope classifier, see um, if any of the edits in its cache relate to if it will determine whether or not any of the edits are in scope in with regards to the input. If it is, it'll go through the counterfact model. If it's not, it'll just go through the base model, and depending on which one it goes through, it'll output a I guess like an answer, right? And so that's essentially how SERAC works. It's pretty neat, and the advantages, it's again, its performance is really good, and it has separation of the base and model editor, so that's also a plus. But again, the disadvantages, it can't make very many edits. It starts degrading at like 75 edits, and it's it relies on a data set of edits, right? So like you have to train both the scope classifier, you have to sorry, train the counterfact classifier, and so it does require a lot of data for training. And yeah, I think that it's a pretty neat solution to model editing, but the scalability is not necessarily there. So, yep. Thank you.